In exercise 509, we're going to look at the volume and surface area of a cylinder. Now, some people actually consider that a cylinder is a prism, and it's a prism because it does have two identical faces, and they are circular, and they are a fixed distance apart, which we usually call the height. And the other thing about it is the formula for the volume of a cylinder can be found by using the same formula as the volume of a prism. So you know that the volume of a prism is that volume is AH, where A is the area of the uniform shape. And because the identical face is a circle, then, and we know the area of a circle is pi r squared, then we can see the complete formula for the volume of the cylinder is pi r squared times h. And that's really about it. It's a nice, fairly straightforward formula. However, it's not on the formula sheet. So, made a note of that. I think reference sheet, not on your reference sheet. So it has to be one that you put in your summary and make sure you learn. The formula for the surface area of the cylinder, however, is, now, I'm just going to jump to the reference sheet. You'll need to scroll back to your reference sheet, and I'll just highlight it here. It's this formula. So could I please get you to name that one as the surface area of a cylinder? I'm going to go back to the notes now. Okay, the surface area. Remember when we did surface area of the prisms? We said we would consider the net, that is like opening your solid out flat. The net of a cylinder consists of a rectangle and two circles, and that's where the formula comes from. This component is the area of your two circles, and we will see examples of where we've got an open cylinder. That means one of the circles doesn't exist, and its surface area formula is just 1 pi r squared rather than 2. Still has the rectangular bit, and the rectangular bit, the area of that rectangular section is found by doing length times breadth. Now, the length is this 2 pi r, which is the circumference, because you know that this rectangular piece has to fit all the way around the circle. So it fits entirely around there. What length would that be? That's what we call the circle. So that's its length, and its width or breadth of the rectangle is the height. And that's where this part of the formula comes from, 2 pi r h. It doesn't look exactly like this on the reference sheet. Whoops. As you can see here, they've left the multiplication signs out, but I'm sure that you know that between the 2, the pi, and the r squared, the multiplication signs, just like in this section of the formula, between the 2, the pi, the r, and the h, there are multiplication signs. So let's have a look at example 23, where it's given you the diagram, which is always nice. Just be mindful that if a diagram's not given, then you should be drawing one. It says a can of soup has base radius 3.7. It's really important to note that they're giving you the radius, and the formula does have radius in it. Sometimes they will try to catch you out by giving you the diameter on the diagram or in the information in the question. So you don't use the diameter value in your formula. The formula just consists of a radius and the height. And the height is 11, we can see that, and it just says what is its volume. So make sure you read the question and note what it is that you're finding. I think I should do that as a highlight. Okay, so find volume. We've got a formula that you remember, you have to learn this one yourself. It's pi r squared h. So it's pi times the radius is 3.7 squared times the height, which is 11. All the units are the same, so we don't have to do any converting. And as you can see there, it's 473.092. And we're given an instruction to the nearest milliliter. Okay, these would be centimetres cubed. Now, what do we know is the connection between a cubic centimetre and a mil? We know that 1 cubic centimetre is 1 mil. Therefore, the volume is equal to the nearest 473 mil. Yeah, I think we've got time in the video to go on and have a look at this next example. A can of tomatoes has base diameter 12. Got to note that. Height 15. Calculate to the nearest square centimetre, that's all fine, units are the same, the surface area of the can. So A, find surface area, which is the formula on the formula sheet, which is 2 pi r squared, 2 pi rh. Now remember, we were given diameter as 12, so when we come to sub into our formula, and the formula clearly says r, and that's a good reason to have it written in front of you, because that says r, whereas we've noted up here the diameter is 12. So we're putting in 6 squared, 2 pi 6 times 15, and 2 pi 6 squared, 2 pi 6 times 15, 791.68, and to the nearest square centimetre will be 792 centimetres squared. Let's have a look at B. The area of the label wrapped around we're to find the area of the label wrapped around the can if there is a 2 centimetre overlap. So instead of the rectangular piece being exactly 2 pi r long, which is the circumference, it'll be 2 pi r plus 2, another 2 centimetres. So that's how we cope with the additional 2 centimetres long. It will still be the 15 high, and just the area of the label then will be our 2 pi r plus 2 times 15. So you can see we've got 2 times pi times 6, add the overlap of another 2 centimetres, multiply by the height. You can see that I've done that there on the calculator, and get 595.48. and calculate to the nearest square centimetre. Now some people think the 8 makes the 4 a 5. Well, it does if I'm cutting off there, but I don't. If I'm just cutting off here to the nearest, I only consider the 4, and the 4 doesn't impact on the 5, so it becomes 959 centimetres squared. Should be right then to make some summary notes and key points and do exercise 509.